Welcome to the Math Record. This video will cover the second part of the ICTM Regional 2017 Division AA Freshman Sophomore 8%, where I'll be covering questions 17 and question 20. Okay, let's begin with 17. Using the grid at the right, determine the number of distinct paths that may be taken from B to A, moving from left and down. Okay, so let's kind of draw this. I don't know how to copy and paste, so I'm just gonna draw this again. So this is a 2, 4, 6, and then 2, 4, 5. So it's a 6 by 5. So 1, 2, 3, 4, and 5, 6. Okay, let's finish this one. And then there's 5 here, but only that one is incomplete. 2, 3, 4, 5. Okay, so just to make sure it's correct. Yep, it is. Okay. So a way to think about how to do this, oh, I forgot to, I'll just draw it in. Basically, to get from here to here, all you have to do is think about the amount of paths that it could be made to get to a vertice. I mean, to like basically an intersection, I mean. So let's say this intersection. How many ways can you get to this intersection? Well, there's only one way. You can only go this way. So there's only one way to get here. Now, what about this? How many ways can you get here? Well, there's only one way. You can only go this way, right? So you can only go 2 to the left. So it's only 1. Now, how many ways can you get here? Well, it's the same case. Well, you can only go 3 to the left. And it'll be the same here, and the same here, and the same here, by the same logic. What about how to get to this vertice? I mean, this intersection. Well, you can only go down. So that's one way to get here. And how many ways can you get here? Well, one way, you just go 2 down. And then to get here, there's 3 down, and then 4 down to only get one way here. Right? So all the ones that are on the side of that point, basically where you're starting from B to A, basically you only have one way to go through it because you could either go only left or only down. Now, how do you go through some of these points where it's inside the grid? Well, we could go from this vertice to go down, or from this vertice and go to the left. So there's one way here and one way here and one way here. That makes a total of 2 ways, right? Because the sum of basically the amount of ways you go through one of the grid vertices is the amount of paths that could basically go through one vertice and then to the other vertice where it's connected. Makes sense logically, right? And then how about this vertice? Well, you could go 2 ways from here and then one way from here. So then you can make a total of 3 ways. What about here? Well, there's 3 ways here and one way here. So that's a total of 4 ways. And then this one would be 5 because 4 plus 1 is 5. So you kind of see the pattern of what's happening. So let's kind of fill out this entire table until we get to A. So this is 3. So 3 plus 3 is 6. This would make 10. And then this would be 15. Now about this one? This will be 4. 1 plus 3 is 4. And then 4 plus 6 is 10. And then 6 plus 10 is 20. And then 20 plus 15 is 35. Okay, now this one. 1 plus 4 is 5. 5 plus 10 is 15. And 15 plus 20 is 35. And 35 plus 35 is 70. Now this one is 6. 6 plus 15 is 21. And I'm just going to fill this one out also. So that's 7. That's 28. Now how many ways can you go down here? Well, there's only one path connected to it going down. You can't go to the left because there's nothing here. So you can only get 21 paths also down here. So how many paths can you go here? Well, you could go this way and this way. So basically, that's 21 plus 28, which gets us 49. And then this way, you could go down or from the left. So that's a total of 56 because 21 plus 35. And then 56 plus 70, which is 126. And then 49 plus 56, which is 105. And then 105 plus 201 will give us our point to A, which is 231. So our answer is 231. Another unique thing about this triangle is that you kind of look about it diagonally. You can kind of see Pascal's triangle. See the 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, right? And then 1, 6, 15, 20, 15. And the reason there isn't like another 6 and a 1 is because this thing isn't fully connected. So it's a little bit like skewed. But basically, this is a way that you can always use to get the answer for the amount of paths. So the answer for this is 231. Okay, now let's go with number 20. In a debate regional qualifier, 60 teams compete head-to-head uh, in a head-to-head competition. There are 6 rounds, either teams win or lose, and then the best record is 6 wins, 0 losses, and the worst record is 0 wins and 6 losses. In order to advance the regional tournament, they must have at least 4 wins or better. Assume that they're all evenly matched. Determine the maximum number of teams that could qualify. So basically, what we need to find out is find out the total amount of wins. And since each team could win 4, then whatever the total amount of wins divided by 4 should be the amount of teams, logically speaking, right? So there's 60 teams. So how do we, so fighting against each of the 60 teams, choosing 6 people they could fight, that seems like a lot of work. So let's kind of minimize it down to, let's say, instead of 60, let's choose, let's say, 10, right? That seems more manageable to do. So I'm just going to make a line, and I'm going to use X's to mark for each of our 10 like contestants, our teams. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are our 10 teams. So we're just going to use a sample size of 10, and then we can multiply by 6 to scale up to 60. So imagine the first team, they have to fight 6 people. So 1, 2, 3, 4, 5, 6. So they fight 6 people. Let's just choose the next 6. So 1, 2, 3, 4, 5, 6, right? So there's a total already 6 games. So let's write that down. So now let's say this team fights 6 people. So 1, 2, 3, 4, 5, 6. And let's say they choose the same 6 people. So 1, 2, 3, 4, 5, 6. So there's another 6 games. And let's say there's another 6 games with this team, and they choose these 6 people again. So 1, 2, 3, 4, 5, 6. So that's another 6 teams, 6 games, I mean. And let's say this final one chooses 6 people, and they fight against these 6 again. 1, 2, 3, 4, 5, 6. So that's 6. And now this team has 4 games already, so they need to play 2 more. So let's say they play against this one and this one. So they play 2 games. And now let's say these two teams fight against each other, so they both get 1 game on each other. Okay, now let's say this person needs to win 2 more, right, to get to 6. So they fight against these two, and that's 2 more games. And now these two fight against each other to finish their last game. Okay, so how many games are there in total? 6 plus 6 plus 6 plus 6 plus 2 plus 1 plus 2 plus 1. So that's 12, 18, 24, 26, 27, 29, 30. So there's a total of 30 games in a sample size of 10 teams. So if we have 60 teams, if we have 60 teams, right, instead, 60 teams, and I'm trying to draw an arrow. How many games will we have? Well, we just need to scale it by 6, right? So 30 times 6 is 180 games. So there's 180 games in total. In each of the games, you have 1 win and 1 losses. So if you have 180 games, you also have 180 wins and 180 losses. But the only part that we care about is 180 wins. So 180 wins. So if there's 180 wins and one team only needs 4 wins to qualify, right? We could just have 180 divided by 4 to get the amount of teams, the maximum amount of teams that could qualify for the tournament. So 180 divided by 4, well, that's 45. And that is your answer for 20. And the reason it kind of works like this is because imagine some teams didn't get 4 wins. Let's say a team got 5 wins, right? Then that we divide by 5. So you get 5 teams to qualify, then we divide by 5, and it would come out as 36. So only 36 maximum teams get qualified. But imagine if, let's say, you only need 4 wins to win, but one team accidentally got 5 wins, right? Then it's going to be 44. Makes sense, right? Because you divide by 4, and the maximum is 45, but one of them won an extra one. So that tells us that out of the 185 wins, 44 of them won 4, and then one of them wins a 5. And then that means only one of the loser teams win one match, which isn't enough to qualify. So this is a logical way to think about it. So just scale down from your 60 to get to your 10, and then to find out the amount of games to find out, which basically gives you the amount of wins, and then do like basically conversion from 4 wins to one team, and you get your answer. And that basically covers the ICTM Division AA Freshman Sophomore 8% 2017. Thanks for watching, and I'll see you at the next math record.